Well, good afternoon. Thank you for the opportunity to speak to you this afternoon. My name is Andrea Basche. I am an assistant professor in the Department of Agronomy. I've been in the department for just under 2 years, but it is a great pleasure to get to talk to you this afternoon about another approach to managing water quality and quantity in our agricultural landscapes. And the way that I think about this in my work is through the principles of soil health. So I will start with a couple of things actually that Charlie teed up really nicely at the end of his talk. Just a couple of things that we know that are important to keep in mind and that sometimes literally keep me up at night. So what do we know? We know that rainfall variability is increasing, right? I don't have to belabor this point for all of us in the room who I presume most of us are from Nebraska and have been through 2019. So we know heavy rain events are increasing. We know we've had longer periods with less rainfall, right? So that is happening right now and impacting communities. And we also know, as has been discussed a few times in the last just hour, a little bit of time since I've been able to be here, that over the same period of time, over the last several decades, as we've seen an increase in rainfall variability, we've also seen a change in our cropping system. So we've lost diversity in our cropping system, right? So, and I'm mostly speaking from the eastern Nebraska side of things, where we predominantly are growing corn and soybean, right? Those are summer annual crops that we plant in the spring, harvest in the fall, that are really only growing, taking up nutrients using water for part of the year, as compared to when we formerly had more winter annual crops or perennial crops in our rotations that were using water and nutrients at different times of the year, right? So what does that leave us with? That leaves us with the situation where our soils are bare and unprotected and susceptible to erosive forces and nutrient loss for more than half the year. And we also know that in these erosion events that we get, in these heavy rain events, that we can have erosion happening in a day at a rate that would take us decades or more to replace that soil by natural processes. So we lose soil much more quickly than we can form it naturally. But those are the not so positive things. But on the positive, that we know the soil can be a solution, right? So I have more of a positive story to tell, especially when we think about managing our soils through principles of soil health. Okay, so I'm in a room with probably a lot more people with water expertise than myself. But the way that I think about soil as a solution is the fact that the soil surface is the point where all aspects of the water cycle are converging, right? This is the place where plants are taking up water to grow. It's where water is infiltrating the soil that's coming from the atmosphere. It's where there can potentially be losses of water through runoff or evaporation, right? Or the way that I like to say this too is that the soil surface, really when it comes to water, is where the action is happening, right? And so even more important when we think about how we can manage with soil health in mind. So I'm presuming that everyone in the room has heard the term soil health. I would say it's kind of a newish term to be used, but the concepts are not new at all, right? So previously soil scientists would have called these ideas soil quality, soil tilth, but the idea of soil health really resonates with people and with a broader audience because we can understand, as the NRCS definition that I have here implies, that soil health is really the capacity of the soil to function as a living ecosystem that sustains life for the future. And I really like this last point here too in the definition when we think about the biological, chemical, and physical aspects of the soil, because they all come into play when we're thinking about soil and water management. So that's definition of soil health, which again, I'm sure intuitively we all are kind of familiar with, but just walking through some of the principles of soil health, which have already been discussed, again, just in the short time that I've been here this afternoon. So this is a diagram from a paper that we just had recently published. A colleague of mine in the department had put this together, but I think it illustrates nicely well the principles of soil health, right? So when we're talking about the known principles or practices that can promote better functioning of the soil, we know that that means integrating livestock. We know that that means reducing the disturbance of the soil through things like conservation or no-till. We know that that means increasing the diversity of plants that we're growing above ground, so crop rotation. And then doing things like cover crops and perennial crops that offer continuous roots in the soil. So I like to look at the principles because we're thinking about principles, we're not just talking about prescribed practices, right? So those are the principles here of soil health. And has anyone seen these infographics before? Okay, see a couple hands raised, right? So these are infographics that I really like from the NRCS that illustrate the idea that these principles, when enacted in the soil, that promote a healthier soil, can lead to better water outcomes of the soil, right? So interesting infographics. This is a pretty widely understood idea, but it's also led me to think about some important research questions that I want to briefly touch on today when we think about, how do we make sense of what these numbers actually mean? What do these actually mean on a field scale? If you have a heavy rain event, what does that mean for a farm? What practices help get us to that point? What are the impacts on experimental fields and producer fields? I'm going to show you just a little bit of data here to that end. And then those infographics also have led me in my research to think about some of these landscape questions, which are very difficult questions to answer. Like, if we had healthier soil at scale, what's the benefit that we might get? And we have some good preliminary information from research I've done that suggests that healthier soil can reduce flood frequency on a larger scale, but I'm not going to talk about that today because I don't have enough time. Maybe another opportunity to do so. But I'm just going to talk a little bit here about these first questions with some of the work that I've done previously and work that I'm a part of now. So this question about, what practices are more effective than others. So this has been published actually just a couple weeks ago, and we had a nice write-up by UNL Communications recently. And in another article that we published last year, as well as a research report that I put together before I got to UNL. But essentially what we wanted to look at were infiltration rates. And this is my favorite part of the water cycle. And I say that in public all the time now. It's totally nerdy, if you can have a favorite part of the water cycle, but infiltration is probably mine. Because it's so critical, right? The rate that water gets into the soil is so important, because that means that water is getting into the soil and not running off and becoming a pollutant, right? And that's water that can then be used by crops. So we looked at this big meta-analysis, several different practices, including some grazing strategies, to see how, if they were compared to a more conventional practice, how much did they impact infiltration rates. So again, infiltration, really important aspect of the water cycle, several different aspects of the soil health principles. And so what we did, it's a little hard to see with the map on this slide, but we found from published research over 120 field experiments and 600 paired observations. So really a big database that we built to try to look at different practices and how effective they were at increasing infiltration rates. And what we found, this is one of the only graphs I have to show you this afternoon, was that those practices that offered continuous cover or continuous roots in the soil were the ones that were most effective at increasing the rate that water got into the soil. So what you're looking at in this graph is just the change in infiltration from these practices compared to a more conventional control. So that the dot is the mean, and then the range in the studies that we found is the error bars, right? So various grazing management, as well as perennial crops versus annual crops, or cover crops versus no cover crops, were the strategies that were most effective. So anything that was around 0, we would say had no effect. No-till, surprisingly, was not more positive. There were some environments that we found where it could have been, but it wasn't as consistently, it wasn't increasing infiltration as consistently as those practices that offered the continuous roots. So this is what we found, again, when we compiled all the work from experiments, at an experimental scale. But I want to also share some work, and I think this was part of the motivation of inviting me to the conference, was to share some of the work that I've been a part of. Oh, here we go. Continuous roots, they were the largest opportunity for increasing water that entered the soil. But I want to share now some of the work that I've been lucky to be included in since I've gotten to the university. So this is related to infiltration and soil health as well. A project that I'm a part of, the Soil Health Initiative. So this is a partnership between the university, Extension, and NRCS. And I see a bunch of folks in the room, Rick Rasby, Dan Gillespie, who was just here from NRCS. I see Aaron Nygren and Gary Leswing and Keith Gluen. This is a great partnership of the university, Extension, and producers who are, they're working with the NRCS. They have equipped contracts essentially to do on-farm research. So they got to select the experiments that they wanted to test on their own farms, And so they have replicated strips that the university helped set up those experiments. But essentially, they picked the design. So we have 17 locations around Nebraska. And I just show this. This is work that the Ph.D. student who's working with me, Fernanda Krupek, who's only started a few months ago, but really done outstanding work already. She is doing a categorization of the different farms because they are using different practices. And the only reason I show this table is just to say, you can see that there are different practices related to soil health that we're trying to group in categories to see, what kind of trends we can find with various soil health related properties. So the one slide I want to show of the results that she's found, she went out this summer with a team and took some soil samples that they're going to analyze for a range of different soil health properties, but they also took infiltration rate measurements. Again, it's pretty easy to do in the field and is very important because it has that direct relationship to heavy wind events. But so she looked at just a few of the farms that have a no cover crop tilled control, which is what up here you're seeing in conventional, the conventional bars. They sampled from a few different counties, a few different farms, several different soil types, and they also looked for a neighboring area where there might have been pasture or a perennial system that was less disturbed. And so I think this was super interesting. When she showed me this data, I was so excited because it really follows the trend that we saw in the big compilation of published studies, right? So we see that in all of those locations and all those soil types, that the tilled no cover crop treatment strips had lower infiltration than those with cover crops that were less disturbed. And then those pasture or rangeland systems either had the same or even higher infiltration rates compared to the others. So again, that really followed the same pattern that we saw in the published study analysis, or the analysis that we published of other studies, right? So super interesting that across the board, about a 60% increase in infiltration when compared to no cover crop. I sometimes like to think about soils as sponges. Here's a nice story that NRCS wrote about one of the producer collaborators who saw some really positive benefits of the cover crop on his farm during the flooding, right? So here they pitched, or they frame the story around his cover crop being like an ark, right? So I think this is great. I mean, he's expressing that the acres that had the cover crop were underwater when the water finally receded. Of course, at that time, we had such an unusual flooding event this year because the soil was mostly frozen, but that when they came out of that frozen period, that he still had a lot of soil intact, and he credited that to his good soil in part because of the crop. So working on experimental farms, working on real farms as well in terms of infiltration. But I just want to wrap up talking a little bit more about water quality. I just have another slide or two here. I got my PhD at Iowa State University, and while I was there in 2012, the nutrient reduction strategy was released, and they still have this table in there that I think is a really nice summary of different nitrogen approaches. So Charlie just talked some about, nitrogen inhibitors, nitrogen management as one piece. They also grouped the impact on nitrate loss, and this was information that they analyzed or just summarized from studies that had been done in Iowa. I know it's not exactly Nebraska, but some similarities, right? So nitrogen management, they looked at cover crops, land use like perennials or CRP, and then edge of field practices. And what I just want to emphasize here is that, again, some of these principles of soil health, cover crops, perennial CRP, extended rotations, right? Those principles related to soil health, those continuous roots in the soil, also offering a lot of opportunity to reduce water pollution as well. And so I have actually not directly measured water pollution coming off of cover crop fields that I've been a part of. Actually, this is a picture from my PhD research where they did a lot of the initial studies around nitrate loss in tile drains in Iowa. But a lot of research has shown the efficacy of cover crops to reduce nitrate loss. And so I'm just showing that here. There actually are 3 synthesis reports that have found similar results. And I'm not going to go into detail about them. It's just the point that these syntheses, one from over 10 years ago and then 2 from the last 2 years, have come to similar conclusions in terms of cover crops reducing nitrate loss by 40, 50, 60, 70%, depending on species and, you know, the amount of biomass that you have. So there's a lot of good work out there to show that these principles of soil health can also go hand in hand with water quality, water quantity. So yeah, just wrapping up. Okay, so you have a reminder of what are those principles of soil health. What I found in my work in terms of the most effective way to get water into the soil is those continuous roots. And again, that there's evidence, especially in terms of cover crops and their ability to improve water quality. Yeah, and then this point again, I think that, you know, when we talk about soil health, like water quality, these two can go really hand in hand together. So that's all I have. Thank you.